Hello students, good evening all. So welcome back to our sessions. So due to the cyclone effect, we couldn't have our few sessions these days. So we are just getting back to our sessions. So today we are going to continue our previous chapter where we have left. So in our previous sessions, we'll just have a brief thing. So first we just entered into our linear inequalities. So after that we started discussing about our quadratic equations, in which we have already finished our session 1 where we had a quick introduction to what is polynomial and what is an equation, the basic difference between those two, as well as we have seen what is a quadratic equation, right? So these kind of things we have already seen in our previous session, right? So let's quickly have an overview of in detail what we are going to discuss in our today's session, right guys? So yeah, as I mentioned, quadratic equation, we have seen the definition of it in our previous session itself. So what is the general form of a quadratic equation? So it is nothing but ax square plus bx plus c is equal to 0. And we have known that a is nothing but it's a the coefficient of x square where the value of a cannot be equal to 0. Right, so you can have b0, c0, but if we want to take it to be an quadratic equation, then the a value which is present here, that is the coefficient of x square, cannot be equal to 0. Right. And then apart from this quadratic discussion, we have even discussed a long division method. If you guys remember, right, so we can actually, if we have any two quadratic, like it's not about a quadratic, so you can have any polynomial. So if you have any polynomial, how you will be dividing one with the other? So that we have seen using the long division method. Yes or no guys? Right. So using in this long division method, we can actually get the remainder. But the trick here is, the thing here is, long division method is a bit lengthy. Right. So that's why we can even find our remainder without using this long division method. That is nothing but by applying the remainder theorem. Right, so this also we have discussed and we have done questions related to this long division method as well as the remainder theorem. So that's a quick recap of what we have discussed in our first session of our quadratic equations. Right guys, so coming to our today's session, we are going to start with the different methods which we will be using to solve any quadratic equation.
right? So in our previous session, what we have seen that okay, there is what is a quadratic equation and what basically the roots are or the zeros are, and those kind of definitions and all we have seen, but we haven't discussed, right? So how we'll be finding those roots? So how we'll be finding the zeros or the solutions of the given quadratic equation? So to get the solution, like to get the solution of any quadratic equation, there are few methods. So you can apply any of the method. It's up to you. If it's mentioned in the question, you have to follow the appropriate method and go ahead and find the solution of the quadratic equation. So guys, so today's session we are going to start with the methods of solving quadratic equations, right? So after that, we'll be discussing about the nature of roots. So you might have already aware of like what we'll be having in nature of roots, right? So we'll be basically discussing about the discriminant, right? So what happens when discriminant is greater than 0 and what happens if it is less than 0. So those kinds of things we are going to discuss, which is nothing but nature of roots, right? And then we'll be having the relation between the roots as well as the coefficients, right? So here, if we take the general quadratic equation, which is nothing but given by ax square plus bx plus c is equal to 0. So this is nothing but my quadratic equation, that is my general quadratic equation, right? So in this quadratic equation, what are my coefficients here? So a, b and c. So these three values are nothing but my coefficients which are present in my quadratic equation. Then what about roots? So roots are nothing but, here we know that the degree is 2. So how many solutions we will be having? 2. So let it be x1 and x2. In general, if we take, so let it be alpha and beta. Standard notation. Right. So my roots here will be that my solution here will be alpha and beta and the coefficients are ABC. So we are going to see the relation between the coefficients which are ABC and our roots alpha and beta. Right. So here we are going to see this relation not only for a quadratic equation, you can even see for a cubic equation, you can get for a biquadratic equation. So any of that kind, right? So once we are aware of one thing, then we can actually write the corresponding remaining things also, right? So that's our next thing, relation between the roots of the quadratic equation and the corresponding coefficients of it, right? And last thing which we are going to cover in our chapter of quadratic equations is the maximum and the minimum values, right? So here we'll be seeing what will be the maximum value of that quadratic equation, right? And what can be the minimum value. So this is nothing but, we can even say the extreme values, which is nothing but maximum and minimum, right? So this is our final and last concept in our chapter of quadratic equation. With this, we can actually wind up the session, right? So what are the topics that we are going to cover in today's session, guys? So we are going to cover, the first thing will be methods of solving the quadratic equation, and the second thing will be the nature of the roots, and the third thing will be the relation between the roots and the coefficients, and last the final one, which is maximum and minimum values here, right? So these are the concepts in our today's highlight. So let's get started with it, guys. So in this methods of solving quadratic equation, the first method is nothing but factorization. If you guys remember, factorization is nothing but, you might have already seen this in your lower sections, right? So let me take a general quadratic equation, that is ax square plus bx plus c is equal to 0. So now my thing is how I'll be doing my factorization. So first thing will be whatever my coefficient of x square, that into my constant term, which is AC, right? So my product of this AC number, for suppose let it be 4, right? So if my product of these two will be 4, then my b should be written in terms of such way that this bx should be expanded into two different factors where the sum of these two, so let me take the factors to be some beta and gamma and okay, let me write it like this. Okay. So let this take some p here and some q here. So the bx can be split into two factors, where the two factors here I have taken is nothing but p and q. Right? If the factors here are p, q, then how can we split this bx into p, q? Such a way that the product of this p, q should be equal to product of our a and c. Similarly, the sum of this p and q should be equal to our constant value b. Right, that means we are going to write our coefficient b, which means we are going to write into two factors such a way that those two factors relation should be, the product should be equal to AC and their sum should be equal to b. Right, so that's how we have to do it. So let's just take an example here. So if I'm having 2x square plus 4x plus 2 is equal to 0. If this is the case. So what is my product? Here this 4x has to be splitted here into two different factors p and q. Right. So let me take this p and q. So my p, q here, what should be the product of it? So the product should be 2 into 2, that is 4, and their sum should be equal to 4. Then possibly what can be the pq values, guys? So the pq values are nothing but both 2. Right. So I can write this here as 2x square. So my 4x can be written as two factors, that is p value 2, so 2x, and q value also 2 here, that is 2x plus 2 is equal to 0. And then further we can simplify it by taking common. So let's just do that. So we are having a quadratic, that is 2x square plus 4x plus 2 equal to 0. So we got our p and q values, both are nothing but 2, so 2x, q 2, so 2x. So this will be rewritten as 2x square plus 2x plus 2x plus 2 is equal to 0. So now from these two terms we can take 2x common. Then here x will be remaining, so plus 1. Right. So here whatever we are taking, so same thing has to be taken common. So here what we can take common? Here we can take 2 common amongst these two. So if we take 2 common, here also we will be having x plus 1, same factor which is here in the previous case. So again we can take x plus 1 common. Here it will be 2x plus 2 is equal to 0. So this is how we will be doing the factorization of any quadratic equation. So once we done the quadratic factorization of it, so what are the factors here? One is x plus 1 and the other is 2x plus 2. This should be equal to 0. So our roots here, that means our solution here for this quadratic equation is x plus 1 is equal to 0, which implies x is equal to minus 1 and 2x plus 2 is equal to 0. That means 2x will be equal to minus 2 and x will be minus 1, which means here we are having two equal roots. Right. So this is how we will be finding the solution of any quadratic equation using the method of factorization. Right, guys? So moving on to the next one, that is algebraic method. So here algebraic method is nothing but a simple basic formula. So we'll be having a quadratic equation formula, like for finding the solution, we have to just simply apply the formula. So let's see what will be the formula for finding the solution of quadratic equation. So first let's write our general form of quadratic equation. Ax square plus bx plus c is equal to 0. So this is my general equation, that is my general quadratic equation. So now my solution my solution, that is nothing but formula here, which will be equal to my formula. Using this solution, using this formula, I am going to find my solution. So this is given by minus b plus or minus root over b square minus 4ac by 2a. So here in the given quadratic equation, we will be having all the coefficient values a, b and c. It's just that we have to simply substitute the values in the given formula and we will be getting the answer here. Right, so as we know, there will be two roots for a quadratic equation. So here according to formula, one root will be minus b plus root over b square minus 4ac by 2a, and the other root here will be minus b, here minus. So minus root over b square minus 4ac by 2a. Right, so here the thing which is present inside the square root is called to be a discriminant. Right. So here the expression which is present inside the square root is nothing but b square minus 4ac, which is called to be discriminant, which is denoted by the capital letter of D. Right. So in our introduction, I have mentioned that we are going to discuss about the nature of roots. Right. So we will be deciding the nature of roots based upon this discriminant only. Right. So here we should be aware of what is the discriminant and what is the expression of it. So discriminant will be equal to b square minus 4ac. So now we can write our formula, that is our formula for finding the solution. We can write that in easier way, that is minus b plus or minus root d by 2a. So here d is nothing but the discriminant which is given by the expression b square minus 4ac. Right. So let's just simply see the same question which we just seen for an example. So 2x square 4x plus 2 equal to 0. So this is what we have seen. Right. So what is my formula? That is minus b plus or minus b, or let it be discriminant under root by 2a. So first let's just find the discriminant here. The discriminant value, the discriminant expression is nothing but b square minus 4ac, guys. So what is the b value? This is our coefficient of x. So 4 square will be 16 and 4, and a value is 2 and c value is 2. So here 16 minus 16, which is my discriminant value, turns out to be 0. Right. So if my discriminant value turns out to be 0, then what about my roots? My roots are nothing but minus b by 2a. Yes or no? Because plus or minus 0 doesn't matter. So my roots will be minus b. So what is b value? So minus 4 by 2, that is 2 into 2, which is minus 1. So which means I'll be having the same roots here, which are equal to alpha and beta will be equal to minus 1 here, which means same roots. Right. So this is how we can solve our any given quadratic equation either using a factorization method or using a algebraic method, which is very easy to get our solution of quadratic equation. So as of now we have seen the methods here. So let's just have some questions related to this. So here comes the first question, guys. Can you guys quickly solve it? Because just now I have explained the factorization method along with the example also. So some of you might have already aware of this factorization method, very familiar with it. So it's easy for you guys to do the factorization and finding the solution of the given quadratic equation. So quickly solve it and let me know the answer. I'll be waiting for your answer. If anyone has done solving it, so quickly let me know the answer, guys. So it's okay, here I have mentioned the method. So if I hadn't mentioned the method of solving it, then it's up to you. You can choose any of the method and go ahead and find the solution. But here in this question, I have mentioned you to follow the method of factorization and find the solution of the given quadratic equation. So let's see what is the quadratic equation which is given: 2x square plus x minus 300 equal to 0. So I'll just give you time, guys. Quickly do it. So you just see what is the coefficient of x square as well as the constant term. I know here the product is huge value, but you can do it. Because the difference here should be plus 1. So let's see if anyone has done it. Okay. It should be 2x plus 25 and x minus. It should be x minus 24. Can you check once? Because 2x plus 25 is perfect, but x minus 24 is not perfectly correct. Can you check it once, Alan? So here this x has to be splitted into two factors. So let it be p and q. Right. So this product should be equal to, so PQ product should be equal to minus 600 and the sum here should be equal to 1. Right. So what are those numbers? So we can see the factors of 600. So the factors of 600 we here will be, so it's related to 25. So 25 into 24. Right. So we can take P 25 and Q 24. Right, where the product is plus 600, but we should get minus 600 and the difference and the sum here should be plus 1. So I am going to take plus 25 and minus 24. Then if I do my product, so my P here will be 25 and Q here will be minus 24. So if in case if I do my product, then it will be minus 600 only, and if I do my sum, that will be 1 only. Right, so my factors here which I have splitted are nothing but 25 and minus 24. So let's just write that. So 2x square plus 25x minus 24x minus 300 equal to 0. So these two there is no common, but I can write 24 here. So let me rewrite this. Minus 24x plus 25x minus 300 is equal to 0. So amongst these two I can pull out 2x, which is a common, and here x minus, if I take 2 common, so here it will be 12. Yes or no guys? So as I have taken 2x common, here I will be remaining with 12 alone. So here I will be having the same term, that is if I take 25 common, x minus 12, which is equal to 0. So then I can entirely take my x minus 12 common and I will be having 2x plus 25. So this will be equal to 0. So after the factorization of given the quadratic equation, we end up having the factors to be x minus 12 and 2x plus 25. Then what about the solution here? 1x will be equal to 12, that is x minus 12 is equal to 0, where x will be equal to 12, and the other will be 2x plus 25 should be equal to 12, then x will be equal to minus 25 by 2. Right guys, so I hope you have checked your mistake, maybe it will be a small one. So yeah, so this is the solution of our quadratic equation, where one x value is given to be 12 and the other is given to be minus 25 by 2, which is minus 12.5. Right, so let's move on to the next question. So here comes one more question. So I hope you can give it the answer quickly. So same type of question, but I just simply changed the quadratic equation here. So in this question, the quadratic equation which is given here is 2x square minus 5x plus 3 equal to 0. So if we observe, if we compare with the previous one, this will be a quite easy. I hope you can give me the answer. So let's just wait for few minutes so that you can just give me the answer, guys. Same procedure, same methodology, only the equation is different. So the numbers will be changing, that's it. So follow the same procedure, guys, which we have just now discussed. So here, so I hope someone has given the answer. So let's see the answer here. How are we going to solve this? So this has to be splitted into two factors, P and Q, where the product of P and Q should be equal to, so 3 into 2, 6. And the sum of this should be equal to minus 5. Right, so it's simple that 1 into 6. Right, so 1, it should be minus, so minus 6 and 1. Product will be minus 6. Sorry, product should be 6, right? then it should be, no, it shouldn't be not 6 1, because sum shouldn't be here, product should be 6, the sum should be -5. Then we can take -3 and -2. Yeah. So 6 and 1, if I write, I am getting minus, if I take the case of 6 and -1, product is coming to be -6. Whereas my sum is also, so -6 plus 1. Yeah, we are getting sum also. We can go by this also, or else we can go by 2 and 3 also. So let's just do it. Okay. So 2x square minus 5x plus 3 equal to 0. So my product should be 6, positive 6. So initially I have taken, so it should be positive 6, right? So initially I have taken -6. So that's why 6 and 1 case will not be satisfying. So I just took it wrong there. So my product should be 6 and sum should be -5. So what is the possible case? Because if we rewrite and write 1 and 6, it's not satisfying. Because if it is, if we take -6 and 1, there our sum is actually -5. Whereas the product is actually -6. But we should get the product to be 6. So that's why our 1 and -6 case will be getting cancelled. Excuse me. So, what about the other chances? So, 2 into 3. So, 2 into 3 will be 6 product. Then what about sum? It is +5. So, what if I take -2 and -3? Then my product will be 6, positive 6, as well as sum will be -5. So, I'll be writing that 2x square minus 2x minus 3x plus 3 is equal to 0. So, let's take 2x common, x minus 1. So, here I can take 3 common. So, let me take -3 common. Then it will be x minus 1. Then it will be x minus 1 and then 2x minus 3 is equal to 0. Then what about the roots here? What about my solution? X is equal to 1 will be one solution and the other, that is 2x minus 3 equal to 0. So x will be 3 by 2. So the two roots of my given quadratic equation here is okay. Okay, yeah, I also did the same mistake. So here I have just taken to be plus -6, same as yours. So it happens when we do the questions. So no need to worry. So here our solution is x equal to 1 and x equal to 3 by 2. So maybe that's the issue. We took time to solve this. So yeah, that's the mistakes we'll generally do in examinations. Like we have to be cautious when we are dealing with the question. Right. So I hope you get it. So yeah, let's move on to the next one, guys. So here I'm giving one more question, but here the method which I have mentioned here is you have to use the quadratic formula. So come on, Alan, quickly solve it and let me know the answer. So it's just application of our formula. So let me write the formula here. So it is minus b plus or minus b square minus 4ac under root by 2a. So this is the quadratic formula. So everything is given here. All our coefficients A, B and C are given. So it's just that we have to substitute and we get the final answer. So let me just see whoever gives the answer. let's see how many of you given the answer. So by comparing with our general equation, you can get all the coefficient values. So what is our general equation? Ax square plus bx plus c is equal to 0. So by comparing these two, what is the a value? Which is equal to 2. Then what about b value? Is equal to 1. And then c here is equal to minus 528. So you have to be cautious when writing the coefficients because it includes the sign also. So that's why I just told you to compare with our general form of quadratic equation. So yeah, Ellen given the answer 32 and 33. Can you check it once? Some mistake because it's not matching with the answer. Just quickly have a review. Just see. Meanwhile, I'll just try to solve it here. So let's just substitute the values. So minus 1 plus or minus. So b square 1 minus 4. A is 2 and c minus 528 under root by 2a. So 2 into 2, 4 here. So minus 1 plus or minus. I just have to get my square root value. So it is 528 into 2 into 4. Which is 1 plus 4224 under root by 4. So if it is 1 plus 4224 means it will be equal to, so let me write it here, let me just write it here, plus or minus 4225 under root by 4. We just have to get the square root expression here. So let's see what is the square root value. So let me just find it out. So 4225. So this is 65. So 1 plus or minus 65 by 4. So 1 root. So 1 will be, let it be alpha. 1 plus 65, that is 66 by 4. And the other will be beta, that is 1 minus 65, that is minus 64 by 4. Right. So 66 by 4 is 1 root and minus, minus. So minus, here it should be minus, same mistake. So minus 1 plus 65, it should be plus 64 by 4, 1 root and minus 66 by 4, another root. Right. So alpha here will be equal to, that is we can cancel it in two tables. So 33 by 2 and beta will be equal to, it will cancel in 4 tables. So 16. So yeah, so these are our roots. One will be equal to 16 and the other will be equal to minus 33 by 2. So I hope you just got your answer. Okay, perfect. So yeah, so let's move on to the next one. Yeah, same thing. Just I have changed the equation. Quickly do it. So by applying the formula, you can just solve this in 1 minute, I guess. So quickly let me know the answer. It will hardly take 1 minute. That's it. So come on, just it will take 1 or 2 minutes hardly. Quickly do it and let me know. So I'll just write you the formula for your reference. So minus b plus or minus b square minus 4ac under root by 2a. So today I'll just give you some questions for homework. So if at last, if time permits, we can try and solve that also. If not, we'll just do that as homework. So if you have any doubts in that, we can have a discussion in our next session. No issues in that. So here roots does not exist because you will be having a negative. So exactly does not exist. Perfect. Because you will be getting the square root expression in terms of negative. So now you have seen this case, right? Roots does not exist. So what does it mean here? So let's just do that here. So now we are going to deal with the nature of roots. So just now we have seen a question where the root expression, that is our discriminant value, is actually negative. Which means what does it denotes? What does it talks about? Right. So we determine the nature of our roots, nature of the roots of any quadratic equation based upon the discriminant value. So we know what is the discriminant expression. So if ax square plus bx plus c is equal to 0, if that is our general quadratic equation where a not equal to 0, then the expression for our discriminant is given by b square minus 4ac. And correspondingly, you can get the value using the coefficients. Right. So for this discriminant, we will be having 3 cases to predict the nature of the roots. So what is the first one? The first one will be discriminant is greater than 0. Right. So if the discriminant value is greater than 0, we will be having, so the quadratic equation will be having two distinct real roots. Both are different, so both roots are different, but both are real roots, right? So, and what happens if discriminant equal to 0? So, if discriminant equal to 0, we will be having two equal real roots again. Right, and the last case here is when discriminant is less than 0. So, when discriminant is less than 0, just now like our previous question, so this quadratic equation will be having imaginary roots. So, I hope you guys remembered complex numbers which we have discussed. Yes or no? Right, so there we have what we have discussed in complex numbers. It is nothing but our I and how we'll be finding the solution for a quadratic equation when the discriminant is less than 0. So that is all we have already learned in our, that we have already learned in our complex numbers. Right. So here what does the nature of the roots state here? So if the discriminant is greater than 0, we'll be having two distinct real roots, and if discriminant is equal to 0. So in our previous questions also we have solved one question where we had the x values both are x equal to minus 1, which means it is a equal. So both roots are equal as well as real roots. And the third case where the discriminant is less than 0 and the roots will be completely imaginary. And how we'll be finding that imaginary roots and all we have already discussed in our complex numbers chapter. Right. So let's do a question here. So try and answer this quickly. So it's a bit tricky, like it's not a direct exact question which you will be answering. But yeah, it's actually easy. You can just give it a try. You can answer it. So just you have to just think for a bit and you can just get the answer. It's not that difficult. You just have to follow the question step by step and try to figure it out. So we'll do one thing. So before discussing that, we'll just quickly discuss this relation between roots and coefficients, and then we'll get back to the question. So first we'll see the relation between roots and coefficients. So if we are having a quadratic equation, that is ax square plus bx plus c equal to 0. If this is a quadratic equation, then what will be the relation between the roots and the coefficients? So here alpha and beta will be my roots here, right? So alpha and beta will be the roots of this quadratic equation. Then my sum of the roots, that is alpha plus beta, will be always equal to minus b by a. That means minus of coefficient of x divided by coefficient of x square. Right. Similarly, we will be having the product of the roots also, and the product of the roots is given by c by a, which is equal to here constant term. So the constant term as well as the coefficient of x square. Right. So this is our relation between roots and the coefficients for a quadratic equation. So now you can use this condition, this relation, and you can try and solve our previous question. Yes. So this one. Quickly, I'll just give you few more minutes. Just read the question step by step and try to figure it out what you have to find. And just now I have mentioned what you have to apply the relation between the coefficients as well as the roots. So that's why I just explained that bit part earlier. So come on guys. So here, what is the question? I'm just trying to read the question step by step. Consider the quadratic polynomial f of x. So here they have given a quadratic polynomial f of x, which is x square minus px plus q. Right. So where they have mentioned f of x equal to 0, that means this quadratic equation x square minus px plus q equal to 0. So this will be having prime roots, which means alpha is my one root and beta is my another root. Let me consider that. Then alpha beta here will be prime numbers. So that's what it means here. So both f of x, the where f of x equal to 0 has prime roots, which means this quadratic equation x square minus px plus q equal to 0 will be having two prime roots, which I have assumed to be alpha beta. So now let's apply our coefficient relation, that is, because here they have given p plus q, p square plus q square and all. So p and q are nothing but here the coefficients of our x square, x and the constant terms which are given in the quadratic equation. Okay, someone has given the answer. Yes, exactly 3422, perfectly correct. Correct, Alan. So as you guys got the answer, let me just quickly give it. So my sum of the roots alpha plus beta is equal to, so minus b by a, so it will be p, and alpha beta product will be equal to q. So now they have given p plus q is equal to 11. So in place of p, I can substitute alpha plus beta. and in place of q I can substitute alpha beta, which is equal to 11. Yes or no? So now I can pull out alpha and comma, then I can be it will be end up getting alpha plus 1 into beta plus 1, which is equal to, I am just adding plus 1 on both sides, so it will be 12. Right. So now this alpha plus 1 into beta plus 1 is equal to 12. So this can be written as 3 into 4. Right. So the only possible prime numbers here will be 2 and 3. So my alpha will be equal to 2 and beta will be equal to 3. So once we got alpha and beta, we can find the quadratic equation. So the quadratic equation f of x will be equal to x minus 2 into x minus 3. And the question they have asked is, you have to find the value of f of a. Then what about a value? So a is equal to p square, that is 4, q square, that is 9, 9 plus 4, that is equal to 13. So you have to find the, sorry. So here I just took the a value wrongly. So here let's just, it's equal to p square plus q square, right? Which means we have to first solve this. So let me find the quadratic equation first. So my quadratic equation will be equal to x minus 2 into x minus 3. So let's quickly find the quadratic equation. X square minus 3x minus 2x plus 6, x square minus 5x plus 6. Right, so this is my f of x. So now I have to find the value of a. So a is given to be p square plus q square. So p is nothing but 5, that is 25, and q is nothing but 6, that is 36. So 1, 3, 4, 61. 6 plus 5, it is 11. So 23, 4, 5, 6. Right. So you have to find the value, that is after substituting it here. That's it. Right. I hope you got the thing how to do it. So I am just giving few questions for homework, guys. So this is the first question for homework. So here I have just given some 2 equations and you have to find the quick relation, because this is a quadratic and this is not a quadratic. So this is your homework question, and again one more homework question here. So this will be a quite easy because it's a typical proof question. You can do it easily. Right. Okay. Alan already given the answer. Okay, fine. No issues. So just now we have discussed a relation between the roots and the coefficients of a quadratic equation. Similarly, we will be having a relation between the roots as well as the coefficient for a cubic equation too. So let's see what it will be. So in general, what will be the general form of a cubic equation? It is given to be ax cube plus bx square plus cx plus d equal to 0. So this is my cubic equation. So it's a general form. So if this is my general cubic equation, then my relation between roots and the coefficients is given by, so it's a degree 3. That means it's obvious that it will be having 3 roots. Right. So those 3 roots I have taken to be alpha, beta and gamma. Right. So first one is sum of these 3 roots, that is alpha plus beta plus gamma. So alpha plus beta plus gamma here will be equal to minus b by a. Right. So that is the first one, sum of all the 3 roots. And the second is product and sum of 2 roots. Right. So first we have taken single and now we are going to take product of 2 roots. That means alpha beta, beta gamma and gamma alpha. That is given to be next one. So first we always start with coefficient of x square. So minus b by a. Not coefficient x square, it will be the second term we can say. So minus b by a, and the next one c by a, and the last one is product of 3 roots, that is minus d by a. So the minus will be coming for the alternative things. Right. So for suppose if we want to write for the biquadratic, that is for degree 4. So what will be the general form of equation? Ax power 4 bx cube cx square dx plus e equal to 0. So what will be the first one? So sum of all the 4 roots, that means alpha plus beta plus gamma plus delta, 4 roots, then it will be minus b by a. And the second one, product and sum of two roots, that means alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. So here we are doing product of two roots and then summing it. So as here we are having 4 roots, it will be product and sum will be having 6 terms, which is equal to, first we have started with b, so the next will be c and the alternative minus, so here it will be c by a, right? And for the third one, so now initially 1 root, 2 roots, now it will be 3 roots. So product of 3, that is alpha beta gamma plus alpha gamma delta plus beta gamma delta. That's it. So alpha beta gamma delta, gamma delta alpha, so gamma delta alpha. Right, so this will be equal to the next, that is minus d by a, because sign will be alternative. So initially minus first and then plus and then minus, and the last product of all 4 roots alpha, beta, gamma, delta will be equal to last and final, that is e by a. Right, so likewise you can write for any of the degree. So here for degree 3 we got it to be 3 terms. For degree 4 by quadratic we have written like this, and the sign will be alternative. So minus plus and all. So this is how we will be getting the relation between roots of the quadratic equation and their coefficients of it. Right. So now let's discuss our next last and final concept, that is maximum and minimum. Right. So what is our quadratic equation in general? So the quadratic equation in general form ax square plus bx plus c. Right. So this quadratic equation can also be written as x plus b by 2a whole square minus d by 4a square into a, where d is the discriminant. Right. So we can rewrite this. Right. So but my case here is my maximum and minimum value will be predicted based upon the a value. A value, that is a coefficient of x square. So how it is that possible? If my a value is greater than 0, in our previous session we have seen the graphs of it. So what happens when a greater than 0, what will be the graph of a quadratic equation, and what will be the graph of a quadratic equation when a less than 0? Right. That means when a greater than 0, the graph of a quadratic equation will be something like this. So here if you observe what is the maximum value, so it is going until infinity. So there is no specific maximum value when a is greater than 0. But we will be having the minimum value when a greater than 0. And that minimum value will be at the x value minus b by 2a, which is nothing but, and the minimum value is equal to d by 4a. We can say that minus d by 4a, which is 4ac minus b square by 4a, or we can write this as in this way, minus d by 4a, that means minus discriminant is nothing but b square minus 4a. Right, so discriminant is nothing but b square minus 4ac, and minus of it is given, then it will be 4ac minus b square. Right, that means when the a value of a quadratic equation becomes greater than 0, then the graph would look like something like this, where it doesn't have any maximum value. So that typical quadratic equation will be having the minimum value, and that minimum value will be at x value minus b by 2a, and the value will be equal to 4ac minus b square by 4a. So let's see what happens when a less than 0. So you might have recalled what will be the typical graph. So it will be inverse. So here, what about the minimum value? Minimum value we cannot predict. So it will be going like this, but we can have the maximum value. So when a is less than 0, we will be having, so the quadratic equation will be having a maximum value at the x value minus b by 2a, same thing, and the value will be equal to 4ac minus b square by 4a. The things will be same, like the x value, at what x value the maximum minimum will be coming is same, and the value will also be the same, right? So the only difference is when a greater than 0, then it will be the minimum value, and when a less than 0, then the value will be the maximum value, right? So here you are having a question. So few more questions. I'll just you can take this as homework, all these questions. So I just added more questions so that it will be giving you a huge time for practice. So take these questions as homework. So for this today's session, I have given we have solved quite number of questions in our session, and I have given lots of questions for homework, guys. So please make sure that you work it on these questions, and if you have any questions, any queries, you can get back to me. So this is the first another question for homework, and this will be the another question for homework. So you can take these questions for homework, and you can try and solve all these questions related to a quadratic equation, and get back to me if you have any questions in this particular concept of quadratic equation, or in this particular homework questions. If you have any doubts, you can please let me know in our next session. So you have to try and work it on, then only you will be getting doubts, and then only we can have a discussion, right? So please don't forget and try and do all these questions. And yeah, that's all. So yeah, with this we just finished our chapter of quadratic equations. So most probably in our next session we will be starting a new chapter. So most probably it will be a series and sequence chapter, or else it will be permutations and combinations. So any of amongst these two, we'll just start our next chapter, right guys? So that's all for our today's session. So with this session we have finished our quadratic equation. So if you have any queries, please let me know in the comment section. So that's all for today. So we'll just meet in our next session, which will be starting a new chapter. Thank you guys.